economics friends. What we're going to do in this video, as I think is obvious, is we'll build a key and an answer for the Harry Potter themed practice FRQ covering production possibilities curves. And then you'll be able to use this particular set of processes to be able to hopefully solve the other practice FRQs over PPCs. So, number one, Hogwarts produces two things, Butterbeers and magic wands. Hogwarts resources include workers, factories, electricity, etc. The following schedule indicates some of the points on Hogwarts production possibilities curve. And so you can see that schedule there, points A, B, C, D, and E, varying combinations of Butterbeers and magic wands that Hogwarts can produce, given the resources that they have available. So the first part of the FRQ asks you to graph Hogwarts PPC and label it AA. So first thing, you got to practice good graphing hygiene here. The best way to do this, in my opinion, doesn't have to be this way, but I'm going to put Butterbeers on the vertical axis, and I'm going to number those or scale those by 50s, so 50, 100, 150, 200, 250, up to the maximum number of Butterbeers that Hogwarts can produce of 300. And then I'm going to put magic wands on the horizontal axis, and I'm going to do those by 10. So 10, 20, 30, 40, 50, 60, and they can produce a maximum of 65 magic wands, and so we'll take that out to 70. Now, all you have to do is go through and for each of the combinations, plot the point. Don't have to be too precise here, but you do want to be careful to make sure that your PPC is correctly shaped. I won't take the time to do that. I don't think that's absolutely necessary. If you need help, come see me. But what we're going to end up with here is a production possibilities curve. And I'm going to be careful here. A production possibilities curve that is going to be outward bowed. It's not perfect, but it'll do a good job for us. There we go. There is our AA. Right? Now, if you do plot those points and connect them with a line, you'll see that you also get an outward bowed production possibilities curve. So the next part of the practice FRQ is to label 3 different points on the graph that you just drew. The first is a productively inefficient point, and we want that with a capital I. Productively inefficient is when you have leftover resources. You have resources that you could be using to produce Butterbeer or magic wands, but are not. They are sitting idle. They simply aren't being used to produce anything at all. An inefficient point, a productively inefficient point, would be any combination of Butterbeers and magic wands inside of the PPC. So an example of that, just one example of countless, would be 100 Butterbeers and 20 magic wands. Hogwarts could produce both more Butterbeers and magic wands because at point I, at 100 Butterbeers and 20 magic wands, there are resources that they could use to produce additional quantities of Butterbeer or magic wands. The next one that they want us to label is a productively efficient point with a capital G. Capital G should be our productively efficient point, rather. Our capital G should be anywhere along the production possibility curve. So I will put my capital G there at roughly 195 Butterbeers and maybe 39 magic wands. The exact number doesn't matter. The point is that it's productively efficient because it lies on the production possibilities curve. What that tells us is that Hogwarts is using all of their available resources to produce as much stuff as they possibly can. Any point along the PPC is productively efficient. An impossible production point is our last portion of this question. And an impossible production point lies outside of the PPC. So let's say 300 Butterbeers and 50 magic wands. Label that with a capital Z. That's impossible because it suggests that Hogwarts is using resources they don't even have. They would need to increase the number of resources they have available to achieve point Z. Now, the important point here is if they did get those resources, and you're going to see this in action momentarily, that production possibility curve, AA, would shift outward. The outward shift is reflecting the additional resources that have become available in our hypothetical, theoretical situation here. So there's point B, or I'm sorry, question B. All right, so some analysis questions. Question C. What will happen to Hogwarts' production possibility curve if the country is hard hit by forest fires? Assume that Butterbeer uses wooden barrels and magic wands are wooden. Using the same graph you drew for question 1B, draw Hogwarts' new production possibilities curve and label it BB. Right? So what we need to do is illustrate on the graph. What is happening here? We are burning down Hogwarts forests. They do not have as much lumber. They don't have as much wood in their Home Depots with which to make wooden barrels for Butterbeer and magic wand construction. That means that both Butterbeer and magic wand construction are going to suffer. And so what's going to happen is, doesn't matter the exact amount that it decreases, but both Butterbeer and magic wand production is going to decrease. And as a result of the lower number of trees available to harvest, production possibilities will shrink. The PPC will shift inward. It'll shift. Another way to think of it is to the left. And so BB, production possibility curve BB, needs to be a smaller production possibility curve. Right? Why is that? We need to explain this. Both Butterbeer, abbreviated BB, and magic wand, MW production, will decrease because there are fewer resources that can be used to make magic wands and Butterbeers. Question D. What will happen to Hogwarts' production possibilities curve if immigrants equally skilled at Butterbeer brewing and magic wand production arrive in the country? We need to use the same graph again. We're going to draw a new PPC. This time we will label it CC. Well, immigrants are labor. If we increase the number of laborers available in an economy, and those laborers can make both Butterbeer and magic wands, then what will happen is we can make both more Butterbeer and magic wands, and that will shift our production possibilities curve outward. Again, it doesn't really matter how much. We don't really know. We simply know that those immigrants, that's labor, now can increase production of both Butterbeer and magic wands. Our text explanation, our text answer is both Butterbeer, BB, and magic wand, MW production, will increase. Question E. What will happen to Hogwarts' production possibilities curve if the country's cows are infected with mad cow disease, limiting the availability of dairy products, of which butter is an example and is used to produce Butterbeer, but not magic wands? Using the same graph as in question 1, draw Hogwarts' new production possibilities curve and label it DD. So now we have a little bit of a wrinkle. We have now reduced a resource needed for one of the products, but that reduction does not affect the other product. The problem with cows only affects Butterbeer production. It does not affect magic wand production. The result is that our Butterbeer production is going to decrease, but our magic wand production is not going to change. And yes, this is getting rather messy, but you'll see that this is very possible. If a resource is changed and that particular resource is only used for one of the goods, that is the good whose production possibility will change. You don't have to change both sides of the PPC. Nothing says that that has to happen. It can be a single-sided shift. And so for question E, our text answer is that butterbeer production decreases, but magic wand production stays the same. All right, so we get down to F and G, and this is going to involve a little teeny tiny bit of arithmetic. It's going to involve our per unit opportunity cost formula. I'll add that on the left here. It's what you give up over what you gain. And so what we're being asked in F is Hogwarts is producing at B, but they would like to move to C. Well, let's take a look at our schedule and see what happens when we do go from B to C. Well, at point B, we are producing 225 butterbeers and 25 magic wands. When we shift to point C, we have decreased butterbeer production to 150 and increased magic wand production to 45. In other words, we are giving up 75 butterbeers and gaining 20 magic wands. We're giving up 75 butterbeers, gaining 20 magic wands. We go back to the question. That means that one magic wand is going to cost, we give up 75 butterbeers, and we're going to gain 20 magic wands. Right? Now you could divide that on a calculator. You could just simply reduce it to its lowest form, whatever your math teacher would say. Either way, you'll get the correct answer. That's 15/4 of a butterbeer. Or if you use your calculator, you'd find out that is 3.75 butterbeers. Okay. G is going the opposite direction. F wanted to know what one magic wand cost over a particular range. G is asking about what does one butterbeer cost. Okay, so we're going to go from point E to point D. So let's go back to our schedule. We start at point E, where Hogwarts is producing 0 butterbeers and 65 magic wands. When they move to point D, they're going to be producing 75 butterbeers and 60 magical wands. That means that they are gaining 75 butterbeers and giving up 5 magic wands. That means that our formula, what we give up over what we gain, is going to be 5 magic wands over the 75 butterbeers we're gaining. This reduces to 1 over 15. So every time Hogwarts produces a butterbeer, they have to give up 1/15 of a magical wand. If you want to run that through a calculator, it comes out to something like 0.06 of a magic wand. I would say that's unnecessary in this particular instance, but if you like the calculator work, knock yourself out. So our last question, question H, does then butterbeer production exhibit increasing, decreasing, or constant per unit opportunity cost? So I'll give you the answer and then we'll explain it. It is increasing. You're going to know that because as you increase butterbeer production, each one of those increased butterbeers that you're making costs you increasing amounts of magic wands. So let's look at the schedule and understand that. Do a little bit of erasing here just to have a clean canvas to work with. So let's start at point E when we are producing 0 butterbeers. When we decide to move to point E, when we move from point E to point D, we're going to gain 75 butterbeers. To get those 75 Butterbeers when we move from E to D, we have to give up 5 magic wands. That doesn't show us anything yet. Let's look at what happens. Let's say we have gone from E to D, and now we want to move from D to C. Well, notice that you are going to add an additional 75 Butterbeers. You go from D to C, you get 75 more Butterbeers. But notice now, when you go from D to C, you have to give up 15 magic wands. When you originally went from E to D and gained 75 Butterbeers, those 75 Butterbeers only cost 5 magic wands. But your second 75 Butterbeers, going from D to C, cost you 15 magic wands. You can already see that as you might produce more and more Butterbeers, those Butterbeers are getting more expensive. You have to give up more magic wands to get the same number of Butterbeers. You want to keep going? We go from C to B, you gain another 75 Butterbeers, but notice now those 75 Butterbeers from C to B cost you 20 magic wands. A further increase in the price of Butterbeers as you increase Butterbeer production. The final shift would be from B to A, where you once again gain 75 Butterbeers, but those last 75 Butterbeers that take you to 300 total cost you 25 magic wands. These 5, 15, 20, and 25 magic wands are where we can see increasing opportunity cost in the production of Butterbeers. Understand that if we had gone from A to B, it works exactly the same way. Magic wand production also shows increasing opportunity cost. As you produce more and more magic wands, moving from A to B to C to D to E, each magic wand gets a little bit more expensive to produce. I hope that helps you work through these practice PPC FRQs. If you need further help, you can always come see me. That's what I'm there for. Talk to you later. See you in class.